Hello and welcome to another section in further mathematics. Today we'll be talking about the nature of graph of trigonometric functions. Now the basic trigonometric functions are sine theta, cos theta, and tan theta. These are the basic trigonometric functions. Now with this, before we proceed, I would like us to do a quick review of our previous lesson before going on with what we have in front of us today. Okay, welcome back. Now when you talk about the nature of graph of the sine, the cosine, and the tangent, there are certain rules that binds the construction of such graph. Number one, let's go into the sine graph. So we call it y. When y, so we have it here, when y is equal to sine theta. Now one thing I want us to note is that the graph of y sine theta forms a wave-like pattern. It is oscillate. So when you talk about being oscillatory in motion, that's it's a to and fro, moves up and down, and the amplitude is usually the same, both at the top part of it and the lower part of it. The maximum value of y sine theta is 1, so the value here is 1, and the minimum value is minus 1, and it occurs when theta is equal to 90 degrees, and the minimum value of minus 1 occurs when theta is equal to 270 degrees. The graph repeats itself at interval of 360. The sine function is an example of a periodic function because it repeats itself at interval of 360. The function is said to be periodicity of 360. So what you're trying to say now is, now this is a graph. It cuts from the origin, travels through 90 degrees where you have its maximum point, and you know, in a wave-like form, this point is called the crest, while the point of minimum displacement is called the trough. It's known as a trough. So this is the crest, this is the trough. The distance from the maximum point to the normal is called the amplitude. This point is called the amplitude, and this point is also called the amplitude. So amplitude in a sine graph, it's experienced at 90 degrees, 70 degrees. The next one will be about 500 and something degrees. That's when you add another about 180 to it. Then you now start going to 270 and beyond. So the length of AE, that is this point to this point on the graph, is known as the amplitude. So there is no stress in trying to draw the sine graph, but this is the nature of the graph. Some of the things you need to know is that it should not exceed +1 and must not go below -1. It must always start from the origin. It should be a periodicity kind of graph that moves in a wave format, just like when wave being generated by plucking a string. The distance between here and here is known as its amplitude. The point of maximum displacement is known as its crest, and this point is called the trough. So this is the shape of the sine graph. Now this is a cosine graph right in front of us. When we talk about the cosine graph, we have similarities between the cosine graph and that of the sine graph. But this graph of y cos theta can be drawn in a manner similar to that of the sine graph. But the only difference is that it is usually at point 90. So it is like 90 degrees behind that of the sine graph. So if it's 90 degrees behind the sine graph, you say that the cosine graph lags. That is not lags. It's called LAGS. Lags the sine graph by 90 degrees. While the sine graph leads the cosine graph by 90 degrees. And one of the things I want us to also note is that the cosine graph did not start from the origin. It starts from a point that is being projected downwards. So if you want to compare the sine graph and the cosine graph, you know that they are both sinusoidal in nature. the mode of operation is a wave-like with the same periodicity of 360, but the difference is that the sine graph projects from the origin, making it a 360 periodicity graph that leads the cosine graph with a 90 degree. When you talk about amplitude, the amplitude of the cosine graph is located at 180 degrees, while that of the sine graph is at 90 degrees, and the next one is located at 270 degrees. There's not much difference between the sine graph and the cosine graph, but the only difference is that the cosine graph lags the sine graph by 90 degrees. So when we talk about the tangent, now tangent have a graph that is not uniform, a graph that projects to a certain point and terminates at a certain point. And one thing about the tangent graph is that tangent does not exist at every point. Now from the graph you can see in front of your screen that the value of tan in 90 is not continuous, so you now produce a dotted and a straight line that projects to the top part of it, and that part is called the asymptote of the tan graph. So when you're talking about the asymptote of the tan graph, it exists at 90 degrees. It also exists at 270 degrees, and the next one will be projected at 180 plus 270. That is where you get the next asymptote of a tan graph. Now let's see some of the features again. The curve consists of 3 parts between 0 and 360. Since the tangent is not defined at 90 and 270, the function is said to be discontinuous. At that point, the curve rises and falls rapidly at an angle very close to 90 degrees and 270 respectively. The curve approaches a vertical line at 90 and this, and never touches them. These vertical lines are called the asymptotes, and most times they are represented with dotted lines. So when you project a dot line with this, you discover that the asymptote of the tan graph exists at every interval of 180 degrees starting from the origin. So one of the unique things I want you to note now is that apart from the cosine graph, every other graph starts from the origin, but the cosine graph originates from a point, a fixed point, and cuts across the 90 degrees. So with this, I'd like us to check a brief comparison between the cosine and the sine graph. Comparison between the cosine and the sine graph. Now we have a pictorial representation of the cosine and the sine graph. Now when you talk about the cosine and the sine graph, just like what we stated earlier, the cosine graph starts from 1, projects down to 90 degrees, cuts across 270, falls beyond, and keep moving in a wave-like form. The same thing is applicable to that of the sine graph, but the only difference is that the sine graph is leading it by 90. So for that same reason, when the cosine is at 90, the sine will be at 180, and when cosine is at 180, sine will be at 270, and when cosine is at 270, sine will be at 360. So there's this interval of 90 degrees between the both. So, and it's called a phase difference, PHASE. It is called a phase difference. So they are no longer in phase because the sine graph is ahead of it by 90 degrees, while the sine graph leads the cosine by 90. The cosine graph lags behind by 90 degrees. I think we've actually done justice in terms of when it comes to explanation of the nature and shape of the sine, the cosine, and the tan graph. So in order for you to be conversant with everything about the nature of this graph, I'd like you to always consult the platform for necessary information on the subject matter. But refresh your memory, always be calm to take the test that will be coming up shortly on your screen. At least it will help you to judge the level of assimilation of the context we just finished discussing. So thank you, and see you in our next lesson.